Good morning, students. Today we will continue with our chapter number 2, the physical and chemical changes. In the last class, we have studied about the physical changes as well as chemical changes. Today we will study about the change of state. Matter exists in the three physical states, namely solid, liquid, and gas. The process of change of a substance from one physical state to another at a definite temperature is called the change of state. There are certain physical changes which are detected by the change of the substate of a substance. For example, when ice is heated, it changes into water, which is a liquid. Water on heating changes into steam. The steam, when it is cooled, it changes back again to water, and water on cooling changes back to ice. Thus, it is said that water exists in all the three states of matter. The different processes which are involved in the change of state of matter are melting, boiling, condensation, freezing, and sublimation. So, we are going to study about all of them separately. Melting. Melting is the process in which a solid gets converted into its liquid state at a fixed temperature. The fixed temperature at which the solid changes into liquid is called its melting point. Now we will do an activity to show that melting of butter is a reversible and a physical change. For this, the materials required are butter, vessel, tripod stand, and a Bunsen burner. We take some butter in a vessel and heat it on a Bunsen burner. We will observe that the butter starts melting. We taste the melted butter. We will notice that there is no change in the taste. This shows that the new substance is not formed here. We will allow the butter to cool. After some time, the butter solidifies and regains its original state. From this activity, we can conclude that when the butter is melted, any new substance is not formed. It only changes its state and becomes liquid. It regains its original state on cooling. So that is why this change is reversible as well as physical. Boiling. Boiling is the process of conversion of a liquid into its vapor or gaseous state at a fixed temperature. The fixed temperature at which the liquid changes into vapor is called its boiling point. Next, condensation. The process in which a substance changes its state from gas to a liquid at a fixed temperature is called condensation. The temperature at which condensation takes place is called condensation point. Now again we will do a small activity to show that condensation is a physical change. For this, the materials required are a vessel, some water, a stove, a pair of tongs, and a stainless steel plate. We take some water in a vessel and heat till it boils and evaporates to become steam. Now hold a stainless steel plate with the help of a pair of tongs against the steam. We will observe that a few water droplets on the stainless steel. These water droplets show the condensation of steam. Since here no new substance is formed, condensation is considered as a physical change. Freezing. It is the process in which a liquid converts itself into the solid state on cooling. The temperature at which a liquid changes into solid is called its freezing point. Sublimation. It is the process in which a solid directly changes into the gas state at all temperatures. For example, iodine, camphor, naphthalene and ammonium chloride are some substances that undergo sublimation. That is, they change from solid to gaseous state without getting converted into liquid. We will again do an activity to show the sublimation of ammonium chloride. For this, the materials required are a funnel, a tripod stand, a china dish, cotton, ammonium chloride, and we take a china dish and put some ammonium chloride in it. Now place the china dish on a tripod stand and cover it with an inverted funnel. Close the opening of the funnel with a cotton plug to prevent the ammonium chloride vapors from escaping into the atmosphere. Now we heat the china dish by using a Bunsen burner. We will observe that ammonium chloride first changes into white vapors and then get converted into solid ammonium chloride on coming in contact with the cold inner walls of the funnel. From this we conclude that ammonium chloride sublimates, which is a physical change. The changes involve energy. Whenever any physical or chemical change takes place, energy is involved. That is, either the energy is absorbed or it is released in one form or the other. The changes that involve the absorption of energy are called as endothermic changes. For example, playing football needs muscular energy, cooking of food, melting of ice needs heat energy, and photosynthesis needs light energy. Therefore, they are endothermic changes. The changes that involve evolution or release of energy are known as exothermic changes. For example, the bursting of firecrackers, burning of the matchstick, on glowing an electric bulb releases the light energy. So these all are the exothermic changes. When a substance is dissolved in water, heat energy is either released or absorbed. If the heat energy is released during the dissolution, that is exothermic, the solution becomes hot, and if the heat energy is absorbed during the dissolution, that is endothermic change take place, the solution becomes cold. We will prove these things with the help of some activities. We will do an activity to show that dissolution of quicklime in water is an exothermic change. For this, the materials required are a piece of quicklime, that is calcium oxide, a beaker and water. We take small quantity of calcium oxide in a beaker, slowly add enough water to the beaker so that quicklime remains submerged in the water. We touch the beaker with fingers to note the temperature. We leave this beaker undisturbed for some time. After some time, we will again touch the beaker. On touching the beaker, we will feel that it is hot. Quicklime reacts vigorously with water to form slake lime, that is calcium hydroxide, releasing a large amount of heat which makes the beaker hot. Thus, dissolution of quicklime in water is an exothermic change. We will do one more activity to show that dissolution of ammonium chloride is an endothermic change. For this, the materials required are ammonium chloride salt, test tube and water. We take a test tube and half fill it with water and add ammonium chloride salt in it. Then we hold the test tube in our hands. We will observe that the test tube has become cooler. This is because ammonium chloride absorbs energy from the water and makes it cool. Thus, it is concluded that dissolution of ammonium chloride in water is an endothermic change. Thank you.